Manila Bay, May 1942. The sun beat down mercilessly on the Corregidor fortress as the last American defenders prepared for the inevitable. Lieutenant Colonel Howard had one final order to execute before surrendering his position. Destroy everything, every document, every codebook, every piece of equipment that might help the enemy. But war makes men practical in unexpected ways. A young Japanese naval officer, Lieutenant Commander Takeo Yamada, stood among the ruins 3 days later, watching his men catalogue the captured American arsenal, mountains of supplies, crates of ammunition, and there, stacked in perfect rows, something that made him pause, M1 Garand rifles, dozens of them, still in their factory grease. Yamada lifted one. The weight felt different from the Arisaka bolt-action rifles his men carried. Smoother action, cleaner lines. He worked the bolt, and the rifle's operating rod cycled with mechanical precision that seemed almost alien compared to Japanese military equipment. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The rifle represented something Yamada understood immediately, American industrial philosophy made tangible. Not the most elegant weapon, not the most refined, but effective, reliable, and apparently, the Americans were arming every single infantryman with one. This wasn't just a rifle, this was a strategic problem. Yokosuka Naval Arsenal, Kanagawa Prefecture, March 1944. 2 years had passed since Manila fell. 2 years of island-hopping warfare, where American firepower grew more overwhelming with each battle. Commander Yamada, now assigned to the Yokosuka Naval Arsenal's machine gun plant, stood in a third-floor workshop, surrounded by the machinery of Japan's desperate industrial effort. The room smelled of gun oil and hot metal. Lathes and milling machines ran constantly, producing 25mm anti-aircraft cannons, Lewis machine guns, Vickers machine guns. Everything ran at maximum capacity. The windows rattled from Allied bombing raids that grew more frequent each month. Yamada had brought several of those captured Garands back from Manila. They'd sat in storage for months until orders came down from Naval High Command. The Imperial Japanese Navy's elite naval infantry, the Special Naval Landing Forces, needed more firepower. Desperately, the problem was obvious to anyone who'd fought Americans. Japanese infantrymen carried Arisaka bolt-action rifles, Type 38 or Type 99 models. Excellent weapons by any standard, reliable, accurate, but bolt action, 5 rounds, cycle the bolt, aim again, fire, repeat. American troops carried Garands, 8 rounds, semi-automatic, pull the trigger. The rifle did the rest, fire, fire, fire. The Americans could put twice the rounds downrange in the same time. In close jungle fighting, this advantage was devastating. Japanese after-action reports painted a clear picture. American squads weren't better trained, they weren't better soldiers, they were better armed, and Japan needed to catch up. The Imperial Japanese Navy had tried before. Throughout the 1930s, various programs attempted to develop semi-automatic rifles. The Type Hei, the Type Ko, the Type Otsu. None succeeded. Cost too much, too complex, too unreliable. Then there was the Pedersen project. John Pedersen himself, the American designer, had visited Japan in the early 30s with his toggle-locked rifle design. The Japanese military, believing this would become the Western standard, poured resources into adapting it. Nippon Special Steel worked on one version, Tokyo Gas and Electric on another. The Army's Koishikawa Arsenal developed a third variant, all based on Pedersen's design. Testing continued for years. The rifles showed promise. Then July 1937 arrived. Japan invaded China. War became reality, not theoretical planning. The costs of fielding an entirely new rifle system while fighting a major land campaign became prohibitive. The semi-automatic programs were cancelled. The Army remained committed to the Arisaka. Logistics were complicated enough without adding new ammunition types, new training requirements, new maintenance procedures. The decision made sense at the time, but that was before Pearl Harbor, before Guadalcanal, before the Americans arrived with their Garands. Commander Yamada received his orders in April 1944. The directive came from high up the chain. The naval arsenal at Yokosuka would develop a semi-automatic rifle for Navy forces. 3 arsenals were originally designated: Yokosuka, Kure, and Mazrui, but all 3 operated at maximum capacity. The war consumed every resource, every machine, every engineer, every worker. The project went to Yokosuka alone, and it wasn't granted dedicated resources or personnel. The order specified this would be a spare-time activity. Engineers would develop Japan's answer to the Garand in whatever hours they could spare from producing anti-aircraft cannons. Yamada read the directive twice to make sure he understood correctly. Develop a revolutionary new weapon system, in spare time. While Allied bombers destroyed Japanese cities nightly, the timeline made the task clear. This wasn't about winning the war, this was about surviving it. He gathered his small team on the 3rd floor of the machine gun plant, 6 engineers, all working double shifts on primary production, all exhausted. Lieutenant Hideaki Matsumoto, a young mechanical engineer from Tokyo Imperial University, Warrant Officer Kenji Sato, an experienced machinist who'd worked at the arsenal for 15 years, 4 other specialists, each with expertise in metallurgy, tooling, or manufacturing processes. "Gentlemen," Yamada began, "we're going to copy the American Garand. We have 10 captured rifles. We have perhaps 6 months. We have no dedicated machinery, no dedicated time, and limited raw materials. Questions?" Matsumoto raised his hand. "Commander, copying foreign weapons is straightforward in theory, but the Garand is a complex machine. It represents decades of American industrial development. John Garand himself spent years perfecting the design at Springfield Armory, their manufacturing tolerances, their materials science, their production techniques. These are all fundamentally different from our capabilities." "Your point, Lieutenant? We're being asked to reverse engineer in months what took the Americans years to develop, with no resources. While under bombardment." Yamada nodded slowly. "Correct. Which is why we're going to take shortcuts. We're not trying to improve on the Garand, we're trying to produce something functional." The first tests began immediately. The team took one of the captured Garands and attempted the simplest possible modification, rechambering it for Japanese 7.7 by 58mm Arisaka ammunition. The cartridges were dimensionally similar to American 30-06 Springfield, length, diameter, overall dimensions, close enough that it seemed feasible. Matsumoto machined a new chamber. They loaded Japanese ammunition. The first test firing occurred on April 23, 1944, at Yokosuka's small arms testing range. The rifle fired. The bullet left the barrel. The gas system cycled. The bolt rotated, ejected the spent cartridge, and loaded a new round from the en-bloc clip. Success, sort of. The second round jammed. The en-bloc clip, designed for slightly different cartridge dimensions, didn't feed reliably with Japanese ammunition. Sometimes it worked, sometimes it didn't. Completely unacceptable for a combat weapon. They tried 9 more Garands. Same result. The gas system worked. The rotating bolt worked. The basic mechanism functioned perfectly. But the en-bloc clip system, Garand's distinctive 8-round clip that loaded from the top, simply wouldn't work reliably with Japanese cartridges. Sato, the experienced machinist, examined the clips carefully. "The tolerance issues are microscopic, Commander. A fraction of a millimeter difference in cartridge dimensions causes feeding problems. We could manufacture new clips machined to exact specifications for Japanese ammunition." "How long? To design and test? 3 months. To tool up for production? Another 6 months at least." Yamada did the math. They didn't have 9 months. They probably didn't have 9 weeks. "We're changing the approach," he announced. "Forget the en-bloc clip. We'll use a fixed magazine." The decision represented a fundamental philosophical split. The Garand's en-bloc clip was elegant. Load 8 rounds from the top. The clip stayed in the rifle until all 8 were fired, then ejected automatically with that distinctive metallic ping. But elegance required precision manufacturing. It required specialized production equipment. It required time Japan didn't have. A fixed magazine was cruder, less refined, but it could work with existing Japanese manufacturing capabilities, and it would use standard Arisaka stripper clips. 2 5-round clips would charge a 10-round magazine. Japanese soldiers already trained with stripper clips. Japanese factories already produced them by the millions. Matsumoto began redesigning the rifle. The challenge was significant. The Garand's receiver, the central metal housing containing the firing mechanism, was designed around the en-bloc system. Changing to a magazine meant redesigning how the receiver seated cartridges, how the bolt stripped rounds from the magazine, how the magazine spring maintained tension. Every change rippled through the entire design. Change the magazine, and you had to change the magazine well. Change the magazine well, and you had to modify the trigger guard. Change the trigger guard, and the stock dimensions shifted. It was engineering, triage. Fix the critical problems. Accept the minor issues. Keep moving forward. By early June 1944, they had a blueprint, a rifle that looked like a Garand externally but internally represented significant modifications. 10-round fixed magazine protruding slightly from the bottom of the receiver, stripper clip guides milled into the receiver top, modified bolt designed to strip cartridges from the magazine at a different angle. But a blueprint wasn't a rifle. The real test would come when they tried to actually build one. Manufacturing revealed Japan's industrial limitations immediately. The Garand's genius wasn't just its design, it was its manufacturability. John Garand had spent years at Springfield Armory, not just perfecting the rifle, but perfecting how to build it. American factories had specialized machinery designed specifically for Garand production, dedicated broaching machines for the barrel, custom dies for forging the receiver, automated grinding equipment for the operating rod. Precision was built into the manufacturing process. Yokosuka Naval Arsenal had none of this. They had general-purpose lathes and milling machines already overworked, producing other weapons. Every Garand part had to be machined individually, by hand, using equipment designed for different purposes. The barrel alone took days. American factories pressed Garand barrels using hydraulic equipment that guaranteed consistent bore diameter and rifling depth. Yokosuka's machinists drilled and rifled each barrel manually, checking dimensions constantly. Sato worked 18-hour days on the first receiver. Forging wasn't possible with available equipment, so they machined it from solid steel stock. Every curve, every surface, every critical dimension hand-cut. It took 3 weeks to produce one receiver. Springfield Armory produced 164 complete rifles per hour at peak production. The first prototype rifle was completed in late June 1944. It looked similar to a Garand. The profile was right, the overall dimensions close, but holding both rifles side by side revealed differences. The Japanese version was heavier, slightly cruder in finish. The magazine protruded from the bottom. The rear sight was a traditional Japanese tangent sight, not the Garand's aperture. The front sight was a barleycorn style familiar to Arisaka users. These weren't improvements, they were compromises born from necessity. Testing began July 7, 1944. The team gathered at the firing range with 5 kilograms of 7.7mm ammunition. Yamada loaded the first stripper clip. The clip slid into the guides smoothly. Good. He pressed down with his thumb, stripping 5 rounds into the magazine. The magazine spring took them. Also good. He loaded the second clip. 5 more rounds. The rifle now held 10. He shouldered the weapon, aimed at a target 50 meters downrange, and fired. The rifle bucked. The gas system cycled. The bolt rotated, ejected the empty cartridge case, and chambered a new round. The operating rod moved smoothly. No jamming, no hesitation. He fired again, and again, 10 rounds without interruption. The team exchanged glances. Success, or so it seemed. They fired 200 rounds that afternoon. Problems emerged quickly. The magazine spring lost tension after repeated loading. Sometimes cartridges wouldn't feed properly. The bolt occasionally failed to lock fully into battery. These weren't minor issues. These were fundamental reliability problems. An infantry rifle that jammed every 20 rounds was worthless in combat. Matsumoto traced the problems methodically. The magazine spring used locally produced steel that couldn't maintain consistent tension under repeated compression. The bolt-locking lugs needed heat treatment to maintain hardness, but the heat treatment process they used left the metal slightly brittle. Each problem had a solution: better steel, different heat treatment, modified tolerances. But each solution required time and resources they didn't have. By August 1944, they'd produced 20 prototype rifles. Some worked better than others. The best ones could fire 100 rounds without jamming. The worst ones failed every magazine. None of them met American standards. But Japanese standards by late 1944 were no longer about perfection. They were about adequacy. Commander Yamada compiled his report for Naval High Command. The rifle worked, sort of. With continued development, improved materials, and dedicated production facilities, they might produce a combat-worthy weapon. The key word was might. The response came back quickly. Proceed to production. The Washino Kikai Company in Aichi Prefecture would manufacture the rifles. Yokosuka would provide the technical drawings and initial tooling support. Production was scheduled to begin January 1945. The target was ambitious: several thousand rifles in the first production run. Nobody believed they'd actually achieve those numbers, but orders were orders. Washino Kikai Company operated in an industrial landscape rapidly collapsing around them. The company normally produced precision machinery and machine tools. Like every Japanese manufacturer in late 1944, they'd been converted entirely to military production. The facility manager, Mr. Takeshi Washino, read the Navy's directive with growing concern. They were ordered to produce rifles, but provided no specialized production machinery. They would have to assemble rifles from parts supplied by Yokosuka Arsenal. This wasn't manufacturing. This was assembly work, and even that would be difficult. Allied bombing intensified through late 1944. American B-29 superfortresses struck Japanese cities regularly. The raids targeted industrial areas deliberately. Factories, shipyards, rail yards, the infrastructure holding Japan's war economy together. Washino's facility suffered near-miss damage in October. Windows shattered. One building partially collapsed. Production halted for 3 days while they cleared debris and restored power. Parts from Yokosuka arrived irregularly. Sometimes a crate of receivers, sometimes barrels and bolts. Never complete sets, never enough to maintain continuous production. The workers themselves were increasingly unavailable. Men were drafted. Teenage boys replaced skilled machinists. Women with no industrial experience worked the assembly lines. Food rations decreased. People were hungry, exhausted, sick. By early January 1945, Washino had assembled perhaps 50 rifles. Most remained incomplete, missing minor parts, waiting for components that might never arrive. The rifles sat in the factory warehouse, covered with protective oil, waiting for an army that was running out of time. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Tokyo, February 1945. The War Cabinet met in an underground bunker as American bombers droned overhead. The discussion had moved beyond victory. Now they spoke of survival, of defending the homeland, of Operation Ketsugo, the plan to resist American invasion with every available resource. Minister of Munitions Toyoda Teijiro reviewed production reports with growing despair. Steel output had dropped 40% since January. Aluminum production, critical for aircraft, had nearly ceased. Coal mines flooded faster than they could be pumped. The transportation network crumbled under relentless bombing. "What about the naval arsenal's new rifle?" someone asked. "The semi-automatic design. Are we producing them?" Silence. Toyoda consulted his notes. The Type 4 program, approximately 50 rifles assembled. Another 100 sets of parts exist but remain unfinished. The Washino facility reports they cannot continue production without consistent parts supply, which Yokosuka cannot provide. Why not? Yokosuka Naval Arsenal is operating at 20% capacity. Allied air raids destroyed 2 machine shops in January. Another was damaged by earthquake. The remaining facilities prioritize ammunition production and ship repairs. The mathematics were simple and brutal. Japan couldn't produce rifles fast enough to matter. They couldn't produce the steel to make the rifles. They couldn't produce the machine tools to work the steel. They couldn't even transport the rifles if they somehow manufactured them, because the rail system was collapsing. The Type 4 rifle program represented Japanese engineering at its most desperate. Smart men working impossible problems with inadequate resources and no time. They'd done remarkable work under the circumstances. But circumstances were everything. Commander Yamada sat in his office listening to Emperor Hirohito's radio broadcast. The war was over. Japan surrendered unconditionally. Around him, engineers and workers wept, some from relief, some from shame, some simply from exhaustion after 4 years of total war. Yamada walked down to the 3rd-floor workshop, where they'd developed the Type 4 rifle. The machinery sat silent for the first time in months. No Allied bombers overhead, no air raid sirens, just quiet. Lieutenant Matsumoto stood beside one of the prototype rifles, disassembled on a workbench. He looked up when Yamada entered. "Commander, I was just examining the bolt assembly. I think I finally understand why we could never match American reliability." "Tell me." Matsumoto held up the bolt. "This component requires heat treatment to achieve proper hardness. The Americans use electric furnaces with precise temperature control. We used coal-fired furnaces with variable temperatures. Each bolt came out slightly different. Some were too soft, some too brittle. We could never achieve consistency." "That's not a design problem." "No, sir. It's an industrial capacity problem. The Americans solved these issues decades ago. They built the machinery, trained the workers, established the quality control systems. We tried to replicate their results without their infrastructure." Yamada nodded slowly. "We were trying to copy the endpoint without understanding the path that led there." U.S. Navy personnel arrived to inventory Japanese military equipment and secure any useful intelligence. Captain James Morrison, U.S. Army Ordnance Corps, led the small arms inspection team. A career ordnance officer with 2 decades of experience, Morrison had spent much of the war evaluating captured enemy weapons. Japanese small arms didn't impress him generally. The Arisaka rifles were solid enough, but represented old technology. The Nambu pistols were mechanically interesting, but poorly suited to combat conditions. Most Japanese weapons showed good craftsmanship, but dated designs. Then his team found the Type 4 rifles. 20 complete rifles sat in a storage room, covered with cosmoline. Another 30 rifles in various states of assembly lay on workbenches. Parts for perhaps 100 more filled wooden crates. Morrison picked up one of the completed rifles. He recognized it immediately. "This is a Garand." His sergeant examined another rifle. "Not quite, sir. The magazine's different, and these sights. But yeah, definitely Garand-based." They spent 2 hours photographing and documenting the rifles. Morrison's trained eye catalogued the modifications. Fixed 10-round magazine instead of en-bloc clips. Japanese-style sights. Different stock dimensions. Chambered for 7.7mm Arisaka ammunition. But the gas system, the rotating bolt, the operating rod, all pure Garand design. Morrison found Commander Yamada the next day. Through a translator, they discussed the Type 4 program. Yamada explained the timeline, the challenges, the compromises. He was surprisingly forthcoming, perhaps relieved to finally talk about the project with someone who understood the engineering. "Why did you use a fixed magazine instead of the en-bloc clip?" Morrison asked. "We couldn't manufacture the clips reliably. The tolerances were too tight for our production capabilities. The fixed magazine was cruder but achievable with available equipment." "How many did you complete?" "Perhaps 125 rifles total. 50 at Washino Kikai Company. Another 75 here at Yokosuka. Many remain unfinished." Morrison made notes. "Did any see combat?" "No. We completed the first production rifles in early '45. By then, the strategic situation made distribution impossible. What were the major problems you encountered? Yamada considered the question. Everything. Material quality, heat treatment, manufacturing precision. Each problem had technical solutions, but we lacked the industrial capacity to implement them. We were trying to match American production standards with Japanese wartime industry. It was impossible. He'd spent years evaluating captured weapons. German small arms were generally excellent, well-designed and well-manufactured. Soviet weapons were crude but effective, optimized for mass production. Japanese weapons were well-made but often based on outdated designs. The Type 4 was different. It represented a Japanese attempt to copy the most advanced infantry rifle in the world, and it showed exactly why Japan lost the war. Morrison compiled his report over the following weeks. The technical details mattered less than the broader implications. The Type 4 rifle wasn't a failure of Japanese engineering. It was a demonstration of industrial capacity determining warfare. He wrote, "The Japanese Type 4 rifle represents a competent reverse engineering effort constrained by insurmountable industrial limitations. Japanese engineers understood the Garand's operating principles and produced a functional copy. However, they could not replicate American manufacturing capabilities, material science, or quality control processes. The result is a weapon that works in ideal conditions but lacks the reliability, durability, and consistency required for military service." More significantly, Morrison continued, the program reveals Japan's desperate strategic position by mid-1944. A nation with adequate industrial capacity doesn't waste scarce engineering resources copying enemy weapons in spare time. The Type 4 program demonstrates that Japanese military leadership understood their infantry firepower disadvantage but lacked means to correct it. Between 1937 and 1945, Springfield Armory produced approximately 3.53 million M1 Garand rifles. Winchester repeating arms added another 514,000. Peak production at Springfield Armory in January 1944 reached 122,000 rifles in a single month. 122,000 rifles, in 1 month, from one facility. The Japanese Navy's Type 4 program produced approximately 125 rifles over the same month. Perhaps, the production ratio spoke for itself. For every Type 4 rifle Japan completed, America produced nearly 976 M1 Garands. But the disparity went deeper than simple numbers. American production operated with consistency. Every rifle built to identical specifications, every part interchangeable, every unit meeting stringent quality standards. American soldiers could swap components between any two Garands and know they'd fit properly. Japanese Type 4 rifles varied significantly. Early prototypes differed from later production models. Rifles built at Yokosuka weren't identical to those assembled at Washino. Parts weren't fully interchangeable. Quality varied depending on available materials and which workers performed the assembly. American production efficiency came from decades of industrial development, Henry Ford's assembly line principles, Frederick Taylor's scientific management, standardization and mass production elevated to national strategy. Japan's industrial base never achieved this level of systematic efficiency. Japanese manufacturing emphasized craftsmanship and artisanal quality, skilled workers producing excellent individual items. This worked brilliantly for producing katana swords or precision optical instruments in limited quantities. It failed catastrophically for modern industrial warfare, requiring millions of standardized components. American factories didn't just outproduce Japanese factories. They operated in different universes of scale. Take steel production. In 1944, the United States produced approximately 80 million tons of steel. Japan produced approximately 5.8 million tons. America produced nearly 14 times more steel than Japan, but Japanese steel production was already declining by 1944. Allied submarine warfare destroyed Japanese merchant shipping. Raw materials couldn't reach factories. Finished products couldn't reach the front lines. The entire industrial ecosystem collapsed. Aircraft production showed similar patterns. The United States manufactured approximately 96,000 aircraft in 1944. Japan produced approximately 28,000. But American aircraft were increasingly sophisticated designs like the P-51 Mustang and B-29 Superfortress, while Japanese factories struggled to produce updated versions of the Zero fighter. Ships, tanks, trucks, artillery, ammunition. Every category showed the same overwhelming disparity. Admiral Yamamoto Isoroku, commander of the Japanese Combined Fleet, supposedly said after Pearl Harbor, "I fear all we have done is to awaken a sleeping giant and fill him with a terrible resolve." The quote may be apocryphal, but the sentiment was accurate. Yamamoto had spent years in America. He understood American industrial capacity. He knew Japan couldn't win a prolonged war of production. The Type 4 rifle program crystallized this reality in miniature. Japan's best engineers, working at one of their premier naval arsenals, spending months trying to copy an American rifle, produced barely enough examples to equip a single company. Meanwhile, American factories turned out Garands by the tens of thousands monthly. Commander Yamada and his team were skilled engineers. They understood the Garand's operating principles. They successfully reverse-engineered a complex weapon system with minimal resources. In different circumstances, with adequate time and proper industrial support, they might have produced an excellent rifle, but circumstances were everything. By 1944, Japan's industrial capacity was collapsing. Allied bombing destroyed factories faster than they could be rebuilt. Raw materials were unavailable. Skilled workers were dead or drafted. Transportation infrastructure crumbled. The engineers at Yokosuka weren't trying to build a better rifle. They were trying to build any rifle at all, and even that proved impossible at scale. John Garand didn't just design a rifle. He designed a rifle that could be mass-produced by semi-skilled workers using automated machinery with consistent quality. Every decision optimized for manufacturing. The gas system used a simple drilled port rather than a complex muzzle trap. The operating rod was a single machined piece rather than multiple components. The receiver could be forged rather than laboriously machined from solid stock. Garand spent years at Springfield Armory, not perfecting the rifle's accuracy but perfecting its manufacturability. He worked with production engineers to develop specialized tooling. He simplified components to reduce machining time. He standardized dimensions to ensure interchangeability. The M1 Garand that American soldiers carried into battle was the endpoint of this process. Not the most accurate rifle possible, not the most powerful, not the lightest, but the most reliable semi-automatic rifle that could be produced in massive quantities with consistent quality. This was American pragmatism made steel. Good enough, produced fast enough, in sufficient quantities to overwhelm any opponent. Japan tried to copy the rifle without understanding the industrial ecosystem that made it possible. Like trying to copy a watch by examining the finished product without understanding the factory that produced it. Modern industrial warfare required systematic thinking about production, logistics, and sustainability. It wasn't enough to design excellent weapons. Nations needed the capacity to manufacture those weapons in quantity, maintain them in the field, and keep troops supplied with ammunition. Germany learned this lesson too late. They produced technically superior tanks like the Panther and Tiger, which spent more time broken down than fighting. Mechanical complexity required specialized maintenance by trained technicians. Parts shortages immobilized entire divisions. The Soviet Union understood the lesson early. Their 34 tank wasn't as sophisticated as German armor, but it was reliable, maintainable by ordinary soldiers, and produced in staggering quantities. Crude but effective, like the Sherman, like the Garand. Japan never fully grasped this principle. Their military philosophy emphasized warrior spirit and superior training. They believed one Japanese soldier equaled 10 Americans. They built beautiful weapons with excellent craftsmanship in small quantities. Then they encountered American industrial production and discovered that quantity had a quality all its own. Captain Morrison returned one final time before shipping back to the United States. He wanted to see Commander Yamada again. They met in the same office where Yamada had planned the Type 4 program. Allied occupation had been remarkably Civil. The Americans weren't vindictive, simply professional. They inventoried everything, documented everything, and prepared to dismantle Japan's military industry. "I wanted to thank you," Morrison said through the translator. "Your candor about the Type 4 program has been valuable for our intelligence reports." Yamada nodded. "May I ask you a question, Captain?" "Of course." "The M1 Garand. How long did development take? From initial concept to full production?" Morrison considered. John Garand began work in the early 1920s. The rifle was officially adopted in 1936. Full production didn't really begin until 1940 or so. Call it 15 to 20 years of development. And we tried to replicate it in 6 months. You came remarkably close, actually. The fact that you produced any functional rifles at all is impressive. But not impressive enough. Morrison understood the unspoken question. "Commander, you asked earlier about the major problems you encountered. You said everything. Material quality, manufacturing precision, industrial capacity. You were correct, but there's a deeper issue." "Which is?" "The Garand isn't just a rifle. It's the product of American industrial culture, mass production, standardization, interchangeable parts, systematic process improvement. These principles didn't originate with Garand. They came from decades of American industrial development, from Eli Whitney's interchangeable musket parts in 1800, from Henry Ford's assembly lines, from Frederick Taylor's time motion studies." Morrison gestured around the arsenal. "Your engineers are excellent, your craftsmen are skilled, but you were trying to replicate the endpoint of 100 years of American industrial evolution in 6 months. That was never going to work." Yamada was quiet for a long moment. "We thought we could substitute spirit for industry, that our soldiers' determination would overcome material disadvantages." "How? Did that work out?" "Not well, Captain. Not well at all." American ordnance teams eventually shipped 20 examples back to Aberdeen Proving Ground in Maryland for detailed evaluation. A few ended up in museums. Most were probably destroyed or lost to history. Today, surviving Type 4 rifles are among the rarest military firearms in existence. Perhaps 30 or 40 remain worldwide. Museums treasure them as historical curiosities. Collectors pay enormous sums for the few that appear at auction. Not because they were excellent rifles. They weren't. By any objective standard, the Type 4 was inferior to the M1 Garand it copied, but they represent something more significant than their mechanical specifications. They represent a moment when Japanese engineers confronted the industrial reality of modern warfare and understood they'd already lost. That assessment perhaps overstated the rifle's significance. The proximity fuse probably contributed more to Allied victory. Radar certainly did. The atomic bomb ended the war decisively. But Patton understood something fundamental. The Garand represented American advantages made tangible. A rifle that worked consistently could be produced in massive quantities, maintained by ordinary soldiers, and kept fighting through conditions that would disable more sophisticated weapons. It wasn't elegant. It wasn't refined. It was effective. The Japanese Type 4 rifle represented the opposite philosophy. Elegant in concept, sophisticated in design, but hamstrung by impossible circumstances and inadequate industrial capacity. One rifle equipped millions of soldiers and helped win a world war. The other equipped no one and sat unused in an arsenal warehouse while Japan's military collapsed. Modern military procurement still grapples with these trade-offs. Sophisticated weapons versus simple reliability. Technological superiority versus production capacity. Perfection versus adequacy. The most advanced weapon system is worthless if you can't build enough of them. The most sophisticated design fails if ordinary soldiers can't maintain it in combat conditions. The highest quality engineering doesn't matter if you can't deliver it where needed, when needed. These were the lessons written in the 125 Type 4 rifles that Japan managed to complete. Compare that to 5.4 million M1 Garands. The numbers tell the story. Industrial capacity wins wars. Not courage, not determination, not even engineering brilliance. Capacity, production, logistics, sustainability. The Americans understood this. They built their entire war effort around it. They didn't try to build the best tank. They built the tank they could produce in overwhelming numbers. They didn't pursue technological perfection. They pursued good enough, fast enough, in sufficient quantity. The Sherman tank wasn't as good as the German Panther. The M1 Garand wasn't as powerful as some bolt-action rifles. The American industrial approach sacrificed individual excellence for systemic efficiency, and it won. No record indicates what happened to him after the occupation. Perhaps he returned to civilian engineering. Perhaps he helped rebuild Japan's shattered industry. Perhaps he simply tried to forget the war. Lieutenant Matsumoto eventually became a professor at Tokyo Imperial University, teaching mechanical engineering to a new generation. His lectures occasionally mentioned the Type 4 program, usually as a cautionary tale about attempting impossible tasks with inadequate resources. The Yokosuka Naval Arsenal became the U.S. Navy's Yokosuka Ship Repair Facility. It remains an American naval base to this day. The building where they developed the Type 4 rifle was demolished in the 1950s. No memorial marks the location. The story survives only in scattered museum pieces, declassified intelligence reports, and the memories of men who understood they were attempting the impossible. After the war, as the Cold War emerged, America decided Japan needed defensive military capability. They provided weapons, training, and equipment to the newly formed JSDF, including M1 Garands, the same rifle Japan had desperately tried to copy during the war. America now simply gave them. Japanese soldiers in the 1950s carried Garands, the rifles that had represented American industrial dominance that Japan couldn't replicate despite months of effort, became standard issue for Japanese forces through American surplus programs. One wonders if any Japanese veterans handling those rifles remembered the Type 4 program, if they appreciated the irony, if they understood the broader lesson. America didn't defeat Japan with better soldiers or superior tactics. America defeated Japan with factories, production lines, systematic manufacturing, and overwhelming industrial capacity. The Type 4 rifle crystallized this reality. 125 rifles versus 5.4 million. The mathematics couldn't be clearer. Technical limitations, industrial limitations, resource limitations, time limitations. Japanese engineers weren't stupid. They weren't incompetent. They simply faced impossible circumstances. They were ordered to copy one of the world's most advanced rifles using spare time and limited resources while their country collapsed around them. They were told to replicate decades of American industrial development in months. That they produced any functional rifles at all is remarkable. That those rifles weren't combat effective was inevitable. The Type 4 program demonstrated that in modern warfare, engineering excellence means nothing without industrial capacity to support it. Brilliant design is worthless without means to manufacture it. Sophisticated weapons are useless if you can't build enough to matter. These lessons cost Japan dearly. The war that began with dreams of empire ended with atomic bombs and unconditional surrender. The military that emphasized spirit over materiel discovered that spirit doesn't stop bullets or shells or bombs. And the engineers who tried to copy the M1 Garand learned that some gaps can't be bridged through ingenuity alone. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.